Byte is really unique. Our students have the freedom to build bonus ideas or enhancements into their projects. This keeps the project submissions always interesting, always fresh, and always fun to look at. Every now and then we get these projects where students try something quite unique, something that makes us relook at the entire design from a fresh perspective because this feature has really pushed the design to a limit. Now, once the submission is here, this is for the knife game, part of our intermediate curriculum. This student has given us a choice to choose the look of the game. So for example, I can choose, let's say, whatever backdrop I want. I've got several choices. Let's say I just choose this backdrop. I can choose how my log looks. So let's say I go and choose maybe a red color log, and I can also choose how my knife looks. So let's say I choose let's say a green color knife. Now, when I go back and play this, notice my knife is green, my log is red, and the game looks quite interesting. When I start playing this, however, you notice that the game starts to slow down. See that? See that the game is slowing down. The rotation of the knife has become much slower. In fact, the whole thing has become very, let's say, unresponsive. I still have got three knives to throw down and throw. I'll do that and move to the next level. You can clearly see that this thing is slowed down completely. Let's just throw one more knife because I want to show you something there. I throw this knife. Now notice I go to the next level, two knives come, but again the game seems to be at a good speed. However, okay, so that's okay. But as I start throwing knives, this thing again starts to slow down. Now this really got me thinking as to what's going on. Let us explore what is going on in this. As I said, this is one of those moments where we have to rethink of the way this game is being done and how the code is written. And in fact, the reason I decided to make this video is because once I started thinking about it again, in fact, we came up with a new implementation of something that we had been doing. Let's first understand why is it that the game is slowing down. For that purpose, let us understand how the student has implemented the different features. Basically, there's a choice for the log and there's a choice for the throwing knife. Both of these have multiple costumes, which is perfectly fine. So if I choose, for example, red color, I get red color wheel. If I choose blue color log, I mean blue color log, I get a blue color log, and so on. And the same thing goes for the throwing knife. So basically, I've got all these different color knives, which the student has, painstakingly made and really nice. I basically go and choose this costume. Now remember that the way my throwing knife works is that it gets thrown to the log. At that point, we start checking for any collision, which means that is my knife clone hitting, let's say, another knife, which is a fixed knife, or let's say another throwing knife. Now the challenge here is that my throwing knife has multiple colors. Hence, the student, I mean, and this is a reasonable thing, to do. What she has done is that she has basically put in all these colors as conditions. I mean, that seems reasonable because, I could be playing with any of these colors, and hence, if any of these conditions comes true, that is a problem situation. Now, the question is, why does this slow down? Why does this cause a problem? Well, the thing to understand is that, look, this is a fairly complicated condition, particularly touching color. Now, touching color is let's say computationally intense and so on. Also keep in mind that this is happening forever by every clone. So which means that as we create more and more clones, there's more and more computation going on, and that completely slows down the game. Now let's just illustrate this whole point. Let's say I were to completely remove this condition. Notice the moment I did that, immediately the game seems to have restored its speed. And that's kind of logical because now the computational load is not all that much. So we realize that yes, this is an issue and somehow this needs to be solved. But the question then is, how do I solve it? Because I do have to do this, right? Obviously, so I thought about this quite a bit. Like I said, this is one of those movements which pushes the fundamental architecture. When there was only one color, there was not a problem. I just put, for example, let's say this, and that's how it was. It had been working fine. But now with all these multiple colors, so we really need to think a little bit differently. Now, one thing to think about is that even though this is how we have done it in the class project, this loop keeps running forever. But you think about it, knife, throwing knife and fixed knives are moving at a constant speed, a same speed, which means that if at all a collision happens, that happens only in the beginning, which means only when the knife is generated. What that means is that, in fact, we do not need to run this forever. I should be doing this check for every clone just once. And this is what I've done over here. So basically what I'm saying is that, look, in this case, when I start as a clone, remember, so I've got all those colors in there. I just, say that, okay, instead of checking this forever, wait until you touch a log. Remember, the clone gets created, it gets thrown to the log. I am saying, well, look, just do the check at that moment. If at that moment any of these conditions is happening, you need to lose a life. Now, this is different because this, let's say, multi-pronged OR condition, which is still holding all the colors, this will happen, but it will happen only once for every clone, unlike the previous implementation where we had a forever. So in fact, I would argue that this is a better implementation of the whole game. Notice when I play this game, in fact, there is no slowing down whatsoever. It just keeps working fine. Okay, so I lost a life there. That's okay. But you notice that there is no slowing down whatsoever. And in fact, it's meeting all the conditions that we had. I can choose the color and so on, right? The reason is because, like I said, this is no longer happening forever, and that's perfectly fine. In fact, all I'm doing is that I wait till the log is touched. At that point, I check if any of these conditions is coming true, which means that if I'm touching a fixed knife or I'm touching any of them. In fact, I would argue that this is in general a better solution because computationally this is more efficient and we can do it even with a single color. In fact, there's a bigger message over here that when we build products and software for the real world, many times it happens that we, learn from the feedback that we get from the field. So people use it. We realize that, okay, some things can be improved. Perhaps there's a design flaw there, or perhaps there's a design improvement possible. Something of that sort is going on here. And that's also a message to everybody that, there's always room to improve, provided we look at things critically. Yeah. So on that note, well, take care all. I hope this has been interesting. Do think about it and do push the boundaries because that's how we learn the best. Remember, forever enjoy coding. Take care. Thank you so much. Bye-bye.